Right, given a graph, we want to write a system of equations that corresponds to this particular graph. We'll do this in several steps. We want to identify what lines are contained in this, or what functions, and write them in slope-intercept form will be the easiest way. We'll identify the y-intercept and the slope. That's all we need for slope-intercept form. So we're going to have this triangle area is the area that is enveloped or encompassed by the inequalities. It's a triangle, so there are three boundaries, so we're going to need three inequalities. We'll take this solid one here first, this orange one. It crosses through the y-axis at +1, and if we look at the slope, it's going up 1, 2, 3, 4, 5, and over 1, 2, 3. So we'll rise of 5, run of 3. So we'll have a y 5/3 x minus 1, and we are shading above that line. It's including the line because it's solid, so it is a greater than or equal to. Greater than or equal to, because it's, again, greater than. We're looking at all the shaded area, the values that are greater than or above that line. Again, solid line, so it's or equal to. Next one. We'll take this one. Well, let's not use green. We just used greens on the inside. How about some purple? Look at this purple line. It's dashed, so we're going to have a y, and it's going to be strictly greater than. It's not going to be or equal to because it's a dashed line or a broken line. It's greater than because we're looking at the shaded region above this line, so it is greater than. Again, this crosses at -1, and now we need to find the slope. If we look carefully, there's a point right here, there's a point right there where it goes through, so it drops down 1 and runs 3. So it drops down 1 and it runs 3x. We can look up here, it goes up 1, but to the left 3 to get another point. That's the same slope. Finally, our last formula, our last function that envelops this triangular area is going to be another y, but it's below the line, so it is less than. It's a broken line, so it's strictly less than, not or equal to. It crosses the y-axis at +1, and it has a slope of 1, 2, 3, and over 1, 2, 3. It has a slope of +1. 3 over 3 is 1x, or just y is less than x plus 1. You generally don't have to write the slope if it's 1. So that would be the system of equations, or system of inequalities that correspond to this graph. All right, how do we take a system of inequalities and draw a graph? All right, so system of inequalities. Here are 5 steps. You can pause the video and look at these 5 steps or reference it later on. Let's go ahead and graph some of these. First off, prepare to graph them using slope-intercept form, and then determine if you were to use a solid or dashed line. After you determine those two things, then finally graph the inequality. Then you can determine, label the direction of the shading, and the final shading is where all the inequalities overlap, or the intersection of each one of these sets. Okay. All right, we'll do 2 examples here. All right. Y is less than or equal to 4. It doesn't matter what x is, we're just looking at y is less than or equal to 4. So y is 4, 1, 2, 3, 4. There's the y-intercept, and this is going to be a 0 slope. So this is like y is equal to 0x plus 4. 0 slope, just a horizontal line. It's a solid line because it's or equal to Just continues on forever in both directions. And it is less than or equal to 4. So we're going to be shading in underneath there. So it's just temporary arrows to show which way I'm shading. All right. X is less than -3, or excuse me, X is greater than -3. So 1, 2, 3, negative. It is a, so it's going to be a vertical line straight up and down. And it's going to be a broken line. It's going to be dashed because it's not equal to. So we are going to make a dashed line there, and we're greater than on the x-axis, left and right direction. We're moving to the right of that. So far we have this area, not including above the purple line or pink line, and not to the left of the green line. We're looking at this area. Let's look at our final. Let's look at the final one. We'll use orange again. Y is greater than or equal to x. This is our parent function. Y equals x. Goes to the origin, and it's just a 45-degree angle from the horizontal or the vertical with a slope of 1. It's or equal to, so we are going to have a solid line. Let's we'll sketch that here. It just continues on. And for those of you who want, this also continues on, of course, in both directions. Y is greater than this, so it's above that. We're looking to shade above all the Y values, that's vertical, up and down, so that are greater than in the up and down world is above. And so we are looking at everything below the pink, to the right of the green, and above the orange. We shade that area to find our region enclosed or described by this system of equations. Okay, we're going to do another example. We have 4 of them. These are not in slope-intercept form. I want to put them in slope-intercept form. We could, they're in standard form, which is, you can graph this by using the intercepts. You can fat finger the x and say y is equal to 4, so y is 4. Fat finger the y, x is 4, 1, 2, 3, 4, and we have a nice line there. It's or equal to, so it is a solid line. Let's see if we can draw this without a straight edge. Good enough. Or you can write this in slope-intercept form. Y is equal to -x plus 4. Y-intercept of +4. Slope of -1, down 1 over 1, down 1 over 1, or down 4 over 4. Let's see. We want y is less than or equal to, and so it is, we're shading below this line. So I'm going to just make some small arrows to indicate where we're shading that. All right, next is similar. We can fat finger this to look at y is -1, x is -1. So here's -1, here's -1, and we can connect those dots. Or you can write this, it's going to be orange. Y is greater than -x minus 1 in slope-intercept form. So -1 slope, crossing the y-axis at -1. Well, that is right here. But before we do that, we want to determine if it's solid or a broken line. It's a broken line because it's not including that. So we are looking at this line. Notice the slope of the purple is -1. The slope of the orange is -1. They're parallel. So they should look like they're parallel. Well, our rough sketch turned out pretty nice. It's above, y is greater than -x minus 1, so it's above that. So we're shading above that region. So far we've got a road going here. We've got to stay on the road. We can't get off either shoulder. All right, let's go ahead and cut this to slope-intercept form. We have to move the x over and get rid of the -1, so we'll multiply everything by -1. Moving the x over is going to be a -x, but then we multiply by -1, turns into a positive x. So y is a positive x, -1 times -1 is a +2. But since we're multiplying by -1, we have to switch the direction of the inequality. So now it is y is less than or equal to x plus 2. Conversely, you can say that this is, well, we'll take a look at a different variety or a method to rewrite this on the next problem, the next section. Y is less than or equal to x plus 2, crosses at positive 2, and it's a slope of positive 1, so it's going to go through here, and it is or equal to, so it's a solid line, and y is less than, so it's below this line. We're starting to see where we're coming into this area. Let's see what our last equation does. We can put this in slope-intercept form a little bit differently. If we add y to both sides, we're going to have x is less than y plus 2. And then subtract 2 from both sides, we'll have x minus 2 is less than y. Switch the direction, and we'll have y is greater than x minus 2. Notice it's opened up to the greater side is open up to y here. The greater side is open up to y there. This lesser side is pointing to the x minus 2. The lesser side is pointing to the x minus 2. The convention is the same. We're just this is the same as multiplying by that -1. We switch the inequality. Well, if you're adding y to both sides, it's taking it to the other side. It's effectively the same thing. So let's look at this intercept is -2, and it's a slope of 1. So we're going up 1 over 1, up 1 over 1, up 1 over 1, and it is strictly greater than, so it is a broken line. Notice slope of 1, slope of 1, these are parallel. They look like they're parallel. Y is greater than that, so y is above that. We are shading this direction. Now, I don't have to put arrows out here because that's outside the area. I don't have to put an arrow here because it's outside that area. Again, I didn't do that on the green because it was of no consequence because we're standing between the purple and green, or purple and orange, and now we're between this pink and green. So it is just this rectangular area, because these are 90-degree angles. This is our shaded region that corresponds. This graph corresponds to the system of inequalities that we had. Breaking them down one at a time, graphing each inequality, looking where they overlap to find our final solution.